Welcome students. In the previous class we actually discussed about some different magnetizing methods like single touch method, double touch method, and also discuss about some difference between actually the natural and artificial magnet also, and also we discuss about earth behave as a big bar magnet and why it is possible. Okay, now today we are going to discuss about actually an electromagnet and its actually uses. Okay, and how we can actually find out electromagnet or how we can create electromagnet. Okay, so first here we have to know today that what is magnetizing by induction method. Okay, so first is magnetizing by induction method. Okay, in generally this method is used to make a temporary magnet. Okay, in generally in this process the magnetic properties of a substance last till the influence of magnetizing force actually stay. Okay, that means up to when we actually withdraw magnetizing force, then the magnetic property of substance actually last, or we can say the magnetic properties of a substance is vanished. Okay, so only the magnetic properties of a substance last till the influence of magnetizing force stage. Okay, otherwise actually the magnetic properties disappear when magnetizing force is removed. This process is induction because here we use the method where we do not touch the magnetic substance with any magnet. Okay, it is a temporary method. We can easily say that magnetic induction is the temporary magnetization method. Okay, by the influence of magnetizing force. That means here we take, suppose if we take a, this is a iron nail. Okay, and in this case it is, suppose we take an iron nail and with a clip we just placed like this, and here we just use some iron paper clips. Okay, so these are the iron paper clips. We just take, this is iron paper clips. Okay, and these are the iron paper clips, and this is actually iron nails, iron nail. So if we place some iron paper clips just below the iron nail, then at first we actually see there is no attraction force between iron nail and iron paper clips. But if we take a bar magnet very close to iron nails, this is suppose north pole and suppose this is south pole, this is strong, we just bring a strong bar magnet, or we can say the north pole of bar magnet is brought very near to iron nail, not touched. Okay, then we can see that iron paper clips attracted by iron nails. Okay, that means actually due to field of bar magnet, strong magnetic field of bar magnet, iron nails become magnetized. Okay, that is why actually iron paper clips just attracted by iron nails. Okay, so in this way we can make the iron nail into a magnet. Okay, temporarily. If we just replace or if we remove the position of bar magnet, then we get iron nail against demagnetized in the demagnetized form. Okay, so this process is magnetizing by induction. Induction means actually in this process we make a magnetic substance into a magnet by without conduction method, okay, without touch, okay, by a strong magnetizing field, okay. And also you have to remember that the magnetic properties disappear when when magnetizing force is removed, okay. Now we move our next point, that is what is electromagnet, okay. Simply the question is what is electromagnet, okay. In generally electromagnet is a process of making temporarily magnet, okay. Here you can see here, this is the simple block diagram. If I draw a block diagram like this, suppose this is a soft core iron, okay, or we can say this is core and the material of the core is soft iron, and we take a insulated coil and the insulated coil is wounded around soft core iron, and actually a battery, this is key, suppose this is key or switch, and we take a cell and connect it like this. Here current flow through this circuit actually from positive terminal to negative terminal, okay, in this direction, and due to this current actually the coil or insulated coil get magnetized and it behaves like a magnet, okay. And this type of magnet is called electromagnet because such type of magnets that are made by using electric current, that is called electromagnet, we can say, okay. And in this case actually the magnetic substance around which the coil is wound is called core, that means this part is actually core part, okay. So here you can see this is soft iron core used, and this one is insulated copper oil on copper coil, and here this is key part, and this is the positive and negative terminal of a cell. So in this case also you can see when this circuit is actually closed circuit means actually current passes through this circuit, okay, or we can say switch is on. But if the switch is off, then we get actually no current, that means current is not passed through this circuit, then we cannot get a magnet. That means actually up to which the magnetic property or the magnetic field is last, up to which current is on, okay. Here you can see an activity also. In this activity you just see here in this process actually for this first case you can see easily that here key is closed, this is key is closed, and a cell is connected through this insulated wire or insulated coil, and here this is core. For this case actually this one behave as a magnet, this part is behave as a magnet, that is why actually iron nails attracted by this magnet, okay, temporary magnet. But for the second part actually here current is actually no current is flow through this circuit, that is why it demagnetized, and iron nails actually there is no attraction between iron nail and the pin, okay. So for this process we can say that actually electromagnet is a temporary magnet, okay. And here when actually current is stopped, then it stops behaving like a magnet, okay. Simply it is a, then it is just behave like a just simple magnetic material, okay, not a magnet. So for this case you have to also know that actually materials that is used for the core of an electromagnet. Here you have to also remember the points on which point actually the strength of the magnet depends. So here 3 points. First one is amount of current. Okay, first one is current, second one is number of turns of the coil, and the third one is nature of the material that is used in the core. Okay, actually how? First, current. Okay, in generally the strength of the electromagnet is directly proportional to the amount of the current. If current is more, then we get more strength of the electromagnet. And the second one is simply number of turns in the coil, and for this case also it is directly proportional. That means actually if number of turns is more in the coil, then we get strong electromagnet or strong strength of an electromagnet. And the third one, that is nature of the material of the core. In generally we use soft iron. Okay, because the strength depends on the material or nature of the material of the core. For soft iron, if current is switched off, then it does not retain its magnetism. Okay, that is why we generally use soft iron, because it is a temporarily magnet. Okay, but if we use steel or some type of alloy, then we get a strong magnetic strength. Or if we actually use steel or any special type of alloy in the position of core, okay, and we use a very strong current, then we get a permanent magnet. Okay, but our aim is actually by this process we just make a temporary method. Okay, so we generally use soft iron, because for soft iron, when current is switched off, then it does not retain its magnetism. Otherwise, if we take steel or any type of special alloy in the core and a strong current is passed through this coil, then we get a permanent magnet. Okay, but if we take copper, brass, aluminium, this type of material, copper, brass, aluminium or wood, etc., then we cannot get any type of actually electromagnet. Okay, actually the strength of the electromagnet is very poor. Okay, now we move our next part, that is what is the difference between permanent and electromagnet. So this is the difference. In this difference you can see that for permanent magnet, magnetic properties are permanent. Electromagnet, magnetic properties are temporary and stay only when as the current flow through it. Okay, and for permanent magnet, poles cannot be reversed. We cannot change the pole. But for electromagnet, poles can be reversed by changing the direction of current. Okay, if we change the direction of current, then we can easily get we can easily change the direction of pole, or we can change the actually pole. Now the third one is strength of the magnetic field cannot be changed for permanent magnet, it is fixed. But for electromagnet we can easily change the strength of the magnetic field by changing the amount of current or by changing the number of turns in the insulated coil. Okay, and also the fourth one, it for permanent magnet it does not need an electric current to act as a magnet. So here current is not required, but for electromagnet current is required. So it needs an electric current to work as a magnet. Okay, now we move our next point, that is actually the next point is uses of magnet. So in generally magnets are used in several devices. Okay, or we can say in many devices magnets are used. Okay, suppose at first magnet are used in magnetic compass also. Okay, sometimes magnets are used actually in refrigerator system or refrigerator doors. Okay, closing mechanism. And also you can say magnets are used in computer, television, speaker, microphone. Okay, ATM card, also credit card. Okay, store information. And also you can say magnetic materials is used in computer hard disks. Okay, and some small magnets are used by doctors to remove iron splinter from eyes. Okay, sometimes. Okay, and also you can say magnets are used to making different types of toy also. Okay, and also in industry. Okay, CPR to lift heavy loads by using magnet. Okay. And also you can say that to separate iron and steel object from heaps of metal scrap. Okay, in mining industry to separate iron ores. Okay, electrical bell, electrical motors, dynamo, generators, and also by doctors to remove small iron pieces from wounds. Okay, so there are several uses in different many in many devices we can use magnets. Now we have to know these are the magnetizing method. Now we have to know about also demagnetizing of a magnet. Okay, so here these are the demagnetization method. Okay, so at first these are the demagnetized. We can easily a magnet can get demagnetized by the following way. Okay, in this method we can make them lose their magnetic property. Okay, suppose rough handling. Okay, and second one is dropping the magnet on the floor several times, hammering the magnet several times. Okay, passing AC current through magnet. Okay, and also hitting the magnet uh, to a heavy high temperature. So here you have to actually care and storage of the magnet. And what are the cares? In generally the poles of magnet are left free for a long time. Okay, two tails become weaker. This is called self demagnetization. If the poles of magnet are left free for a long interval of time, they tends to become weaker. This is self demagnetization. Okay, but when two magnets are kept together, there will be mutual attraction or repulsion. Then magnets will lose their magnetic strength over a long time. So to avoid this, magnets are stored using magnetic keepers. Okay, so a magnetic keeper is a soft iron bar. Okay, in generally you have to avoid this type of demagnetization. To avoid this, magnets are stored using magnetic keepers. Okay, a magnetic keeper is a soft iron bar. While storing bar magnet using magnetic keepers, two bar magnets are placed side by side. Okay, with their opposite poles at the same end. Okay, and also by using magnetic keepers in such a way that a magnetic chain is formed. Okay, and magnets do not lose their magnetism. Only one magnetic keeper is required for the horseshoe magnet or U-shaped magnet. Okay, in generally if the poles of magnets are left free for a long time, then they become weaker. This is called self demagnetization. And sometimes actually when two magnets are kept together, their mutual attraction and repulsion force, due to this their magnetic attraction or magnetic repulsion force, the magnets will lose their magnetic strength over a period of time. To avoid this type of actually demagnetization, we have to actually we have to store the magnet using magnetic keepers. Magnetic keepers is a soft iron bar. Okay, and while storing bar magnet, actually using magnetic keepers, two bar magnet are placed side by side. Okay, so that means actually if you placed two bar magnets side by side, then and also you have two placed like this. Here you can see that two, if you take two bar magnets like this side by side, here this is your north pole, this is your south pole, and this is your south pole, and this is your north pole. That means two bar magnet are kept or placed side by side with their opposite poles at the same end. Okay, here you can see opposite pole at the same end. And also you this type of actually magnetic keeper is used. Okay, and also you can use a U-shaped. Okay, horseshoe magnet with this keeper, and here the keeper means you just use any type of keeper like this. Okay, and for this case you just use, this is south, that means you have to use north, this is south, here you just use again south, and in this case north. Okay, and you can use also horseshoe magnet, like suppose if you take a bar magnet, this is your south pole and this is your north pole, then you just use one u-shaped or horseshoe magnet, here you just place north pole. Okay, and here you just place south pole. So this is the care or storage of magnets. So actually in this chapter you know about magnetic force, okay, magnetic field, and it is generally represented by magnetic field lines, two poles, north pole, south pole, and different properties of magnet and magnetic field lines also. Okay, and also different type of magnets, that means temporary magnet, permanent magnet, how we can create temporary magnet, different methods of temporary magnet. Okay, so this is the end of today's class. Okay, in the next class we discuss about the whole exercise problems, okay, of this chapter. Thank you.